So here's a familiar shape that we've all seen. This is the equation of a circle. Now, if we were to find the area of this circle, we know that it's equal to this right here, where you have the area is equal to pi r squared. Well, let's go ahead and find out how we do this using an integral. That's going to equal to the integral from negative r to r. We're going to multiply it by 2, and we have the integral of r squared minus x squared with respect to x. Already know we're going to be using some trig substitution. So whenever we're using trig substitution and we have the constant minus the variable squared, then we're gonna make the variable our opposite. We have the constant as our hypotenuse, and we have the adjacent side as root r squared minus x squared. You can find this using Pythagorean theorem. So now we go ahead and do this representation for the x, and now we go ahead and find our differential. Nice, so we're gonna go ahead and use that. And now we have to find a representation for this root value in terms of theta, which is gonna be this term right here. And now we go ahead and rewrite our integral up this value right here. I don't have any parameters. I'm gonna do that at the very end because I don't wanna write them in terms of theta. I want them all in terms of x at the end. I'm just gonna rewrite the problem. Okay, so let's go ahead and multiply these things together. This r becomes r squared, but it's a constant, so I'm just going to put it on the outside, and now I have cosine squared theta d theta. So I have to remember how to simplify this using a power reducing formula, which looks like this right here. Well, I mean, that's pretty simple. So now we're going to go ahead and rewrite this. There's going to be a 1/2 in here, so I'm just going to pull it out on the outside, canceling this out with the 2. So I have r squared integral of 1 plus cosine of 2 theta d theta. And now let's just go ahead and get to integrating. So we have r squared, and then we still have theta plus 1/2 sine of 2 theta by use substitution or reverse chain rule. Okay, let's go ahead and switch these back into values of x, because we have this right here, and then now the theta is going to become something else. So that's my value for theta. That was pretty simple. This is going to require something else, because I have to rewrite the sine theta as 1/2 times 2 sine theta cosine theta. So really this becomes sine theta cosine theta. And now we just have to switch these using my triangle right here. So this was my value for sine. This is my value for cosine using the triangle that I have here. But then check this out. Now I have the negative r to r. Now I'm going to implement the first fundamental theorem of calculus. But when you plug in r to both of these, you're going to have r squared minus r squared. So that's going to become 0. And then you have r squared minus negative r squared. That's also 0. So this entire thing just goes away. So I'm really just focused on this right here. So when I plug in r and when I plug in negative r, I'm going to get a value of sine inverse of 1 minus sine inverse of negative 1. This is going to become pi over 2. This is going to become negative pi over 2. So now we have this right here, and we simply just add these together, giving us pi over 2 plus pi over 2, which is 2 pi over 2, which is just going to be pi. So pi r squared is going to be the area, and that exactly shows that the area is going to be pi r squared, just as we thought.